The question says that the motion of a particle executing simple harmonic motion is described by the displacement function xt equals a cos omega t plus phi. If the initial time t equals to 0 position of the particle is 1 centimeter and its initial velocity is omega centimeter per second, what are its amplitude and initial phase angle? The angular frequency of the particle is pi per second. If instead of the cosine function we choose the sine function to describe the SHM, x equals to b sine omega t plus alpha, what is the amplitude and initial phase angle of the particle with the above initial condition? So we have been given the initial data of an SHM, and we have to find out the equation of SHM using this cosine form and the sine form. So we know that as the data has been given, the initial position is 1 centimeter and the initial velocity, that is the differentiation of this position x dash t, is omega centimeter per second, and we have to find out phi and a in this equation so that the equation can be SHM equation can be completed. So the differentiation or the velocity time equation of this equation would be a is omega sine omega t plus phi. So upon substitution of this the values, we have got at t equals to 0 the position is 1 centimeter, so cos phi would be equal to 1 by a, and similarly substituting the t equals to 0 in the x dash t form, we get sin phi equals to minus 1 by a. Now using the identity cos square phi plus sin square phi equals to 1, we get the value of a, and that is equals to root 2 centimeter. That is amplitude is root 2 centimeter. Now upon finding out the value of phi or the initial phase angle, we can use both of these equations, cos phi equals to 1 by a and sin phi equals to minus 1 by a. Since we have found out a, that is equals to root 2, so cos phi equals to 1 by root 2 or sin phi equals to minus 1 by root 2. Now we know from these coordinates that in the first coordinate sin and cos is positive, in second coordinate sin is positive and cos is negative, and in third coordinate sin is negative and cos is also negative, and in fourth coordinate sin is negative and cos is positive. So here similarly cos is positive and sin is negative, so the phi is in fourth coordinate. Now we can either write phi equals to minus pi by 4 or phi equals to 7 pi by 4. So the equation comes out to be, equation in the cosine form comes out to be root 2 cos omega t minus pi by 4 or root 2 cos omega t plus 7 pi by 4. Now we have to find out the same equation in the cosine form. So using the same data given in the question, the initial position is 1 centimeter, so that would imply that sine alpha would be equal to 1 centimeter by b. The b is the magnitude in the cosine form, in the sine form, and the velocity plot and velocity equation, according to velocity equation substituting t equals to 0, we get cos alpha equals to 1 by b. Now using the same identity again, cos square phi plus sin square phi equals to 1, we get b equals to root 2. Now since upon calculation for alpha, we get alpha equals to pi by 4 in both the cases, so we can write this equation as root 2 sin omega t plus pi by 4 centimeter. Thank you.